Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 7.54. The statement of problem is determine the principal planes and principal stresses for the state of plane stress resulting from superposition of two states of stress shown. So this is one state of stress and this is the second state of stress. So you have to determine the principal plane and principal stresses due to the addition of or superposition of two states of stress. So you can see these are the normal stresses and these are the principal stresses because there is no shear stress acting. So what we will do is that we will convert first this state of stress into horizontal and vertical component, and then we will add and we will find the principal stress and principal state. So let's start with the solution. So first of all you have to take this right side state of stress and convert it into horizontal and vertical components, as this state of stress determines only the principal stresses. So we will take let me show you. We will take this state of stress that is given over here, that is, let's say this is 45 angle, let's say, and this is the state of stress that is shown clear. So that is 6 ksi and this is also, and this is 4 ksi. And this is the angle 45 degree. Clear? So we will draw its Mohr circle. From Mohr circle we can see this is the principal stress in x dash direction and this is principal stress in y dash direction. So sigma x dash is equal to 6 ksi and sigma y dash is equal to minus 4 ksi. So let's draw its Mohr circle. I will draw it over here. So this is your normal stress. This is your vertical stress. Okay. So on y-axis represent the shear stress and x-axis represent the normal stress. So for sigma x dash 6. And there is no shear stress, so it will be 0. So 1, 2, let one block is 1 ksi. Let's say from this is origin, this is 1 ksi, 2, 3, 4, 5, and this is 6. Similarly, 1, 2, 3, and this is minus 4. So if you plot 6, 0, which will be this one, this point, clear? And for y dash, it will be minus 4. So I will draw a circle. You have to draw the circle by using protractor. I will just adjust the circle over here. You can see if I adjust it, so it will be 1 point will be there, 1 point will be there. So again, so your circle will look like exactly the same. Clear? Now from this you can see that this is sigma x dash, clear, this point, and this is sigma y dash, and this, as these are the principal stresses, so this represent x dash and this represent y dash, and the radius, what will be the origin of this circle? So that is sigma average. Clear? Which is the, let's say this is the OC is the center, so which is sigma x plus sigma y divided by 2. Clear? And sigma x is 6 and sigma y is 4 divided by 2, which is again equal to 1, and that is equal to OC. Clear? Center. So this is origin and C will be at a distance of 1. Clear? So this is OC. So this is the center of circle. Clear? Okay. Now what you have to do is that you can see that the radius of circle is C. Let's say this point is y dash and this is x dash. Clear? So C dash, cy dash is equal to the radius, and that is equal to, this distance is 4 and this is 1. Clear? So this is the radius, which is equal to 5. No need to calculate it again. So this is the state of stress for this element. Clear? Now what we have to do, we have to rotate this element 45 degree clockwise, because if you bring it, if you rotate it 45 degree clockwise, it will be like this. Clear? So what we have to do is we have to rotate this x 45 degree, but in Mohr circle it will be 90 degree. So when you rotate it at 90 degrees, so this will be the center and it will be rotated. So this point will be over here and this point will be over here. Again you have to draw it as per scale. So you will get this new line when you rotate it through 45 degree in this state and 90 degree in Mohr circle. So when you rotate it, it will be like this. Again, it will be like this. Now this will be your new y. Clear? And this will be your x, because you have rotated x dash to 90 degree, so it will be new point x. Now from this figure you can easily say that x is at a distance of 1 from this origin, so you can see that sigma x will be equal to 1 ksi. Similarly, from this Mohr circle, sigma y is equal to, again this is also at a distance of 1 from the origin, it will be 1 ksi, and tau of xy, which is equal to 5. Clear? Because this is the radius. Again this circle is not correct as per drawn figure. So this tau of xy is 5 ksi. You can see it is radius is equal to radius, and that is equal to tau of xy, which is equal to from cy dash, which is 5 ksi. So we have converted this element, this principal state of stress, into horizontal and vertical components. So you can also now represent, so sigma x is equal to 1 ksi. Similarly, sigma y is also 1 ksi, and shear stress is 5 ksi. Now what you have to do, you have to add, this was the second state of stress, so you have to by using principle of superposition, you will have to add with this. So let me draw this state of stress, that is 1. Clear? So we'll choose another marker. Clear? So let's say this was initial state of stress and the stresses is 1 ksi. Sorry, not 1 ksi. This was 5 ksi. 5. I will also show you. Similarly, sigma y was 3 ksi. Clear? And tau of x is equal to this one, 3 ksi. This is also 2 ksi. Let me show it over here. 5, 2, 3. So you can see 5, 3 and 2. So you have to add it with this one. So you have to add, when you add it, let me draw it again over here. So this is 1, clear, and this is also 1, and the shear stress was 5 ksi. I am not writing the units, so this is 5. So when you add it, so the state of stress will be like this one. So 5 plus 1, which will be equal to 6 ksi. So it will be 6 ksi. Similarly, my 3 is in compression and 1 is in tension. So it will be, net will be 2 in compression. So it will be 2. Clear? Shear stress is 5 and here it is 2. So net will be 3. Now this is the resultant or the state of stress due to the superposition of this stress, this state 1 and state 2. Clear? So now we will take this state of stress, the resultant, and we will find the principal stresses and the principal plane for this state of stress. That is being asked from us to calculate the principal stress and principal plane for the resulting state of stress from the superposition of two state of stress. So from this figure you can see sigma x is equal to 6, sigma y is equal to -2 and tau of xy is equal to 3. Clear? So we will use Mohr circle. For Mohr circle we need x and y, and we know that x is equal to sigma x comma minus tau of xy. Similarly, y is equal to sigma y comma tau of xy, and this center is equal to average comma 0. Clear? So let me write 6 comma minus 3 minus 2 comma 3 and sigma average which was 1, that is 1 comma 0. Clear? So let's draw the Mohr circle. For that, again I will take horizontal axis as well as vertical axis for drawing the Mohr circle. Okay. So this x represent the normal stress and vertical represent the shear stress. So first we will plot 6 comma minus 3 and y minus 2 comma 3. So this is, let's say this point is origin. So every block is taken as 1 ksi. So 6 comma minus 3. So 6 is this one, 1, 2, 3, 4, 5, 6, and minus 3 is this one. So this point is 6 comma minus 3 and this is x point. Similarly, y point is minus 2, 3. So minus 1, minus 2 and 1, 2, 3, and this point is minus 2 comma 3, and again this point is y. Clear? So center will be this 1. Clear? So if you join these three points by using a line, so you will get the resultant like this. Again there is a mistake, I think so. Minus 2, 3 and minus 6, minus 3. Let me check it. This is center O. This is 1, 2, 3, 4, 5, 6, 6 comma minus 3, and this is 1. Clear? OC. Okay. So OC is not 1 over here. So you can see that sigma x plus sigma y divided by 2 is equal to 6 minus 2 divided by 2, which is equal to 4 divided by 2, which is equal to 2. So you have to correct it. So this is 2. I should also correct it so that this is the horizontal line. Clear? So your sigma, your point C will lies over here because it is 2 comma 0. Clear? So you have to draw a line that will pass through both these two lines and center, and then you have to draw a circle by keeping the center, by keeping this point C as center, and radius is equal to CY or CX. So you have to draw the circle. Again, I do not have any equipment to draw it, so I will just roughly draw a circle, and then I have to adjust these 2 points, and again I will move it so that it may look like that center is passing through, points is passing through center. Clear? So let this is your circle. Clear? So now you can see that these are the state of stress x and y. In order to find the principal stresses, so there will be principal stresses sigma x dash over here and sigma y dash over here, and we are interested to find that. So this will, if you rotate the element through this angle, which is equal to 2 theta p, so you can find the sigma x dash and sigma y dash as well. So let's move it. So we know that OC is equal to, this distance is equal to 2, and from this point, if you draw a perpendicular line from this point x to this, clear? So you can see that distance from this center C to this will be equal to, this is equal to 4, because the total is 6, which is from 0 to this. So this is 4, so this is, and this is 2. Total is 6, so if you subtract 2 from 6, so you will get this distance. Let this distance is m. So Cm is equal to 4. Clear? And again, now we will find sigma average. Sigma average is also already been found, which is equal to 2, and we have to find the radius r. So this Cx distance or Cy is r. Clear? R, this is equal to r, and you know that r is equal to sigma x minus sigma y divided by 2. This is sigma whole square plus tau of xy whole square. Clear? So you have to put the value that is equal to 6 minus minus will be plus, because sigma y is minus 2, so it will be plus divided by 2 whole square plus tau of xy, which is equal to, again, and that is equal to 3, not 3. Okay, so you can see this is 4, this is 4, and this is 3. So you can use this formula, or by using Pythagoras theorem you can also find this r. So this will be equal to 4 square plus this vertical distance, which is equal to minus 3. So again this minus 3 whole square under the root will give you the r, which is equal to 5, and this r is equal to the, again this will be equal to the maximum shear stress. Clear? So that will be equal to maximum shear, clear, and that is equal to 5 ksi. Clear? So you do not need to find this R by using this formula, because simply you can apply Pythagoras theorem and you can get the maximum shear stress. Again, maximum shear stress R for R. Now you can see this sigma x dash is equal to OC, and let this point is, let's say, N point, and this is K point, let's say. So you know sigma x is equal to ON, which is equal to OC plus this CN is equal to again R. I will write it OC plus CN is equal to R, and OC is equal to sigma average plus R. So sigma x dash, which is a principal stress, is equal to this, and sigma minimum is equal to OK, which is equal to OC minus OK. OK is equal to minimum, which is equal to OC minus R, which is CK, which is equal to R. So also correct it, OC minus R. Clear? Because you know that CK is equal to R, so if you subtract OC from the R, so you will get OK. Clear? So put the value, sigma average is equal to 2 and R is equal to 5, which is equal to 7 KSI. Clear? And sigma minimum, which is equal to sigma y dash, is equal to OC, which is equal to 2 minus R is equal to 5, which is equal to minus 3 KSI. Clear? So we have find out the principal stresses. Now we will find the principal plane. So simply you have to take tangent of 2 theta p is equal to mx over cn. Clear? Again you can see that this mx is equal to 3. Clear? And this cm is equal to 4. So theta 2 theta p will be equal to tan inverse tangent inverse 3 over 4, which will be equal to 36.87 degree. Clear? So T2 theta P1 will be equal to 36.87 and theta P2 will be equal to theta P1 plus plus 180 degree. Clear? So you will get theta P2, 2 theta P2. This is 2. Again, theta P1 is equal to 18.4 degree and theta P2 will be equal to 108.4 degree. Clear? So you have to move the element to 2 theta p in counterclockwise direction, that is either 36.87 degree or 2 theta p 1 plus 180 in counterclockwise direction in Mohr circle. For general state of stress, so you have to, let's say, let me show the smaller thickness. So if this is the smaller thickness, this is sigma x, this is sigma y. So theta is 18.4. So let's say this is your 18.4, this theta in counterclockwise 18.4 degree theta p1. Clear? So if you draw the element, so here your sigma max or sigma x dash will be 7 KSI. Sigma y is minus 3, so it will be like this, minus 3 KSI. And there is no shear stress in the principal plane, so it will be sigma y dash is equal to 3 ksi. So the end of the problem is that we have find out this was the initial first state of stress and this is second. So by using principle of superposition, we calculate out the resultant of the above two and find out their principal stresses and principal plane. I hope you have enjoyed the video. Thank you for watching.